Welcome to my projectbazaar.com. We will discuss about the project for retrieval-based face annotation by weak label regularized local coordinate coding. Social networks such as Facebook, Twitter, etc. are widely used in our day-to-day life. Many of them use human face images for their profile, and also people use celebrity faces. Nowadays, human faces are mostly used for main imputation such as searching and mining. Face image retrieval using content-based method is an emergency technology in many real-world applications. Due to different people having similar faces, problems can be faced while we arrive to retrieve the similar faces. To solve this issue, technology such as retrieval-based face annotation use common outline for same categories of image. For example, kit cap can be set as constraint to retrieve children's long hair of women's. Two main challenges should be faced while we overcome this existing system. This is the first challenge is we have to efficiently shortlist for the similar face images. On the other hand, we have to effectively exploit the shortlist of face image and its weak labeled information that differ from the original image. Our main goal is to retrieve the similar image from large scale database using content based. In existing content based method used low level features retrieve the also it cannot be detect the human face automatically. Low level features are just to approach the position in which we cannot get the exact information whether it's similar human faces. The attributes should be selected effectively as it can be provide a crystal clear result for all the faces in large scale database. By incorporating low level and high level attributes, we can gain promising result to retrieve similar faces. From the large scale database, an efficient optimization algorithm is proposed to solve the weak label regularized local coordinate coding problems. Moreover, an effective sparse reconstruction scheme is developed to perform the face annotation task. We conduct extensive empirical studies and several web facial image databases to evaluate the proposed weak label regularized local coordinate coding algorithm for different aspects. We propose an effective technology which exploits the principle of local coordinate coding. Next, we will see about the flow diagram for the product. First, we browse the input image for any specific location. Then, the input image apply to the pre-processing method. There are various pre-processing methods follow their products. Example for edge reduction, smoothing, image resize, filter the image. Now, this product we use the pre-processing method for filter the image. The median filter to be used this product because in order to improve the quality of the image, we normally employ some filtering operations. Median filter is used for filtering. The median filter consists each pixel in the image is turned in and look at its nearby neighbors to decide whether or not it is representative of this surrounding. Then go to the feature extraction block. GIST algorithm to be used in this block. GIST means generalized search tree. Generalized search tree algorithm to be used in this method. It is a disk-based search tree. In computer vision, GIST descriptor are representation of a low-dimensional image that contains enough information to identify the scene in an image. The GIST descriptor allow very small size representation of the image. After the pre-processing step of the input character image, the next step consists of the changing the character image into different scale and orientation. Finally, the feature vector are calculated by each scale, orientation and frequency. Then go to the database images. Thus the images also apply to the pre-processing method. The pre-processing method used in median filter. Then filter the all database images and go to the feature extraction table. The feature extraction table used for GIST feature algorithm. GIST means generalized search tree. This is the algorithm to all database images are applied. Then create the train feature values for the table. Then the train feature tables apply to the indexing method. the indexing method used for LSKetch algorithm. This LSKetch algorithm means locality sensitive hashing algorithm. The locality sensitive hashing algorithm that allows one to quick find similar entities in large database. This approach belongs to novel and interesting class of algorithms that are known as randomized algorithm. The randomized algorithm does not create an exact answer but instead provides a high quality generates that is will return to correct answer and on close it. Thus the local sensitive hashing algorithm to create the labels and to apply to the labels and images. Then to find the true future train future and labels also comparison at the same time the input face images and the features. Then load the train feature, true feature and true label also appear to the algorithm. Then passed to the weak label regularized local coordinate coding algorithm. Thus the algorithm to be used many blocks. The algorithm to find the top n images and the labels. Thus the algorithm to be used for the classifier, KNN classifier. The KNN classifier means kernel neighbor nearest classifier. Thus the classifier to retrieve the images while comparing the labels of the neighbors of a document. We also consider the semi-supervised version of the KNN algorithm where we look at the enabled neighbors of the document together with its labeled neighbors. The algorithm turns out the equivalent of the semi-supervised learning method based harmonic functions. Then we create the top n images and the labels to be identified and the identification process to be followed by the which correct name of the person to be identified by the final output. Finally, we find out the similar facial images for the input query images. Next, we will see about the output for the product. First, we will browse the input query image. The second image to be selected. Then go to the pre-processing step. Pre-processing step using the filter the image. The filter using in median filter. Then go to the feature extract window. Feature extract window consists of two buttons. One true feature image for the feature descriptor, then displayed by the feature descriptor for the true image. Then go to the feature extract table. The feature extract table to be displayed by the input query image. Feature extract table consists of GIST feature algorithm. GIST means generalized search tree feature algorithm. Next, go to the LSKetch indexing window. The LSKetch indexing for the displayed by the nearest neighbor values for the input query image. Then go to the label propagation. Label propagation means to identify the person for the input query image. Then identify the person to be selected by the input query image. Then go to the top n similar images for the input image. Then displayed by the top similar images for the input query image. Then go to the next window, performance analysis for this algorithm. First, there are three select for the performance: one precision, second recall, then accuracy. The precision values to be displayed by the proposed method. The precision analysis graph to be displayed. Two algorithm graph for performance to be analysis by this graph. Proposed method for values and existing method values to be displayed by this graph. Then go to the recall. The recall values to be displayed by this proposed method, and the recall analysis graph to be displayed for these two methods: weak label regularized local coordinate algorithm and ULR algorithm. Then go to the accuracy value. The accuracy values to be displayed by this proposed method. Accuracy to be 0.975. The 97% of accuracy to be used for this method. the existing method values to be displayed and the proposed method values to be displayed by the accuracy analysis graph. Finally, we will discuss all output for this product.